Hello everyone, welcome to NA's Institute, a complete chemistry classroom program. This is the fifth class of Bioinorganic chemistry. In this class, we will learn about ionophores, that is naturally occurring ionophores or naturally occurring antibiotics. Then we will try to learn different classes of these ionophores and finally mechanism of its action. But prior to start the lecture, we should know that from where the term ionophore has been developed. See that this term ionophore is having two words, right? First one is ion and second one is phore. We are well aware about this term ion and we do know what does it mean. But we didn't hear about this term phore. So basically phore means ion carriers, that such a thing which will carry the ions. So basically with these two terms we are getting the word ionophore. So ultimately, ionophore is a chemical species that reversibly binds ions. If we have to make a definition of these ionophore, then I would say that ionophores are a class of compounds that form complexes with specific ions and facilitate their transport across the cell membranes. And an ionophore typically has a hydrophilic pocket, or it can have a hole that forms a binding site specific for a particular ion. So it will have a hydrophilic pocket. So hydrophilic means that it will attract a particular ion which will be hydrophilic in nature, and the exterior part or the exterior surface of an ionophore will be hydrophobic, because in that case it will allow the complexed ion in its pocket to cross the hydrophobic cell membrane. So there are several naturally occurring macrocyclic and open chain antibiotics which are known to allow the passage of some specific cations across the biological membrane. The exterior portion of these metal complexes with these antibiotics is nonpolar, and the metal will be hidden at the center because the metal is polar, and at the interior part it is actually hydrophilic, so it will attract the metal ion, and the exterior part is hydrophobic in nature, and the complexes are membrane or lipid layer soluble. Why? Because the exterior part is hydrophobic, so it will be the lipid layer soluble, or it will be soluble in the membrane. Thus they act as ionophores or ion bearers. Here actually I am trying to explain the structure as much as possible. The ionophores actually contain these kind of hydrophilic centers that bind specific ions, and a hydrophobic portion that interacts with the lipid interior of the membrane. That kind of thing we have already discussed in the last slide. And the most ionophores adapt a cyclic ring formation by concentrating oxygen or nitrogen functional groups at the center of their structure to associate with the cations. Because in that case, when there would be oxygen or nitrogen kind of elements will be present, then the interior part would be hydrophilic in nature, and in that case it will try to attach with these kind of cations, or it will, the structure will associate with those kind of cations, and with the hydrophobic groups in contact with the acyl groups of the membrane, then the ionophore will be able to dissolve and diffuse to the opposite side of the membrane, and thus it will be soluble in the cell membrane. In terms of the mechanism of transport of the metal ions through the cell membrane, the naturally occurring antibiotics, or these kind of ionophores, can be classified into two groups. First one is the carrier ionophore, and second one will be the channel forming ionophore, which we will discuss elaborately in the next few slides. First, we will learn about these carrier ionophores. See that when do we hear about this term carrier ionophores, the first thing come into our mind that there should be something which will carry the ions, right? So in these type of carrier ionophores, there should be some kind of non-polar shell. Why non-polar? Because the exterior part should be lipophilic or hydrophobic, otherwise it would not be soluble in the cell membrane, right? Because of this hydrophobic or lipophilic nature of the exterior part, only in that case it will pass through the cell membrane, because the cell membrane or the lipid layer is actually non-polar. So the outer part of the shell should be non-polar or lipophilic or hydrophobic, or the interior part itself it is hydrophilic, and therefore it will attach or it will associate with the metal ion, and thus the complex itself diffuses through the non-polar lipid layer of the membrane. Example of that kind of ionophore can be valinomycin, which I have already shown you in the slide. Now we will learn the channel forming ionophore. See that channel forming ionophore means there should be some channel which will help to pass the ions through the cell membrane. See, the channel forming ionophore is almost similar with that whatever we have learned in the last slides, that is ion carriers. So basically see that in case of ion carriers, the exterior part of that ion carrier was hydrophobic or non-polar in nature. So in these case, in case of these channel forming ionophore, the exterior part of the channel should be hydrophobic or it should be non-polar. Why? Because otherwise it cannot exist in the lipid layer of the membrane. So the exterior part of this channel should be hydrophobic, and that's why they can span the hydrophobic lipid layer of the membrane. But the interior part should be hydrophilic, otherwise it cannot associate with the metal atom. So the interior parts of the channels should be hydrophilic, and that's why it will allow the passage of the cations. So there are several examples of these kind of channel forming ionophores, and one of them is gramicidin A, whichever I have already shown you in this slide. Here I have again tried to show you the basic difference between these carrier ionophores and these channel ionophores. See that in the carrier ionophores, the outer part or the exterior part is actually non-polar, or it is having the hydrophobic part, whereas the inside part would be hydrophilic in nature, and therefore it will be associated with the cations. Whereas in case of these channel ionophores, actually the shell or the outer part will be completely hydrophobic, and therefore it only can span the hydrophobic lipid layer of that membrane, whereas the inside part or the interior part would be the polar, and therefore it will help to pass the ions through the cell membrane. So therefore this is the basic difference between these channel ionophores and these carrier ionophores. Here again I have shown you a general representation of these channel forming ionophores and these carrier ionophores. But here actually I wanted to mainly point out on how the metal ion passes through the cell membrane by the involvement of these ion carriers and the ion channels. The first one is the ion carriers through which the metal ion passes through the cell membrane, and second one is the ion channels through which the metal is passing through the cell membrane. So example of that kind of ion carriers are valinomycin, whereas examples of that kind of ion channels would be gramicidin A. Now again, the ionophores can be classified into two categories based on their structural properties. One is class 1 and second would be the class 2. So we will now discuss elaborately what are the class 1 ionophores and what will be the class 2 ionophores. The class 1 are mainly cyclic ionophores, and they are neutral at the physiological pH. Thus their metal complexes will be cationic in nature. And examples of these kind of ionophores may be actins like non-actin. There are other examples like valinomycin, eniatin A, eniatin B like. So the structure of valinomycin is known to us, and therefore I have shown you just one structure of these kind of examples, that is valinomycin. Now, under the class 2 categories, there will be open chain carbocyclic acid ionophores. These can cyclize through hydrogen bonding. They form neutral complexes like RCOO minus Na plus after deprotonation of that COOH group or the carboxylic group. There can be several examples like monensin, dianimycin, etc. And I have shown you just one structure of that kind of example, that is dianimycin, which is reflected on your screen. So this is for today's class. In this class already we have learned what are the ionophores, and these ionophores are actually categorized into two categories, that is channel forming ionophores and then carrier ionophores, based on their mechanism of ion transport. And then we have learned that based on their structural properties also they can be classified into two classes, that is class 1 and class 2. And all things we have just elaborated as much as possible with the explanations also and with several examples also. So if still you have any doubt regarding the class, you can contact us directly through the website www.energinst.com, or you can drop a mail at energinst@gmail.com, or you can directly call, message or WhatsApp us in the given number. Thank you for watching this video, and see you in the next class. Thank you.